Hello students, we will continue our lesson about chemical bonding. This time we'll talk about intermolecular forces. The learning outcome. We review, the types of chemical bonding. The first is interatomic and the second one is intermolecular that we'll talk today. First of all, we want to discuss about polarity of molecule. There are two types of polarity of molecules. The first is polar, the second one is non-polar. And besides the polar and non-polar molecules, you also know the ionic bond, the bond between the positive and the negative ions. Here for polar, we have the example is H2O. Here you see here the electronegativity of hydrogen less than oxygen, so the bond pair between H and O, the electrons will pull toward O, oxygen, meaning that the cloud of electron around oxygen atom is the biggest. We symbolize as delta negative, so the hydrogen is delta positive or positive pole. The molecule like this we call as polar. So H2O is a polar molecule compound. And here non-polar, in covalent bond, the equal sharing of electrons, the electrons between two atoms shared equally, so there is no negative pole or positive pole. For polar, there is positive pole and negative pole. Negative pole here, the atom, meaning that the electron cloud in here, there are more electron in here, so this part is negative. For ionic bond, there is no sharing electron between the bond here separately, but indeed there is strong electrostatic force between the positive and the negative. Slightly positive, slightly negative. Delta positive, delta negative, delta positive. Here what we want to talk about intermolecular forces between non-polar molecule such as CH4, that's non-polar, because the difference between the electronegativity between carbon atom and hydrogens only a little. For polar, for example, HCl, and for a hydrogen bonding, for example, H2O. So intermolecular forces, there are three types. The first is instantaneous dipole, induced dipole, or van der Waals forces between the non-polar dipole-dipole interaction between polar molecule such as HCl. And the third is hydrogen bonding. For example, in H2O, where H binded to oxygen. For intermolecular forces, depend on the type of the molecule. If the molecule non-polar or polar or attached to hydrogen, so intermolecular forces will be different. There are three types of intermolecular forces. The first is instantaneous dipole-induced dipole, or we say as van der Waals forces. The second one is dipole-dipole interaction, and the third one is hydrogen bonding. The instantaneous dipole-induced dipole that exists among non-polar molecule. For a dipole-dipole interaction exists among polar molecule such as H2O or HCl. For a non-polar CCl4. And the third one is hydrogen bonding. When we have the molecule have hydrogen attached chemically to the highly electronegative atom F and NO, H2O or HF, and this between the molecule. So this negatively charged pole here, positive pole, then between the positive pole there is hydrogen bond to the negative pole. Here the negative to the positive, that's hydrogen bond. So London or van der Waals, we can say as London dispersion forces. That's attraction due to the constant motion of electrons. As we know, the electron in atoms remain stuck, but they are moving. This will cause temporary concentration of charge or cloud of electron in one side, and the other side will be positive. But that's temporary. So the positive temporary positive pole will attract the temporary negative pole. We have methane here, CH4. The molecule is tetrahedral, and then the molecule is symmetrical. So the cloud of electrons between C and H equally shared. Then there is weak van der Waals forces because CH4 is a non-polar molecule, but this is weak because that's temporary. Then methane exists as gas at RTP because of the weak van der Waals forces. Because weak, then the molecules will far apart among them. For intermolecular forces, here once again you have three types. The first is London or dispersion forces. Actually, the London or van der Waals forces we can have also in the polar molecule, because the electron moving not only in the non-polar but also in a polar molecule. This based on the density of the electron cloud. The density of electron clouds That's because the electrons moving. The second one is dipole-dipole forces. This exists among the polar molecule only. And the third is hydrogen bonds, special type of dipole-dipole force. When we have hydrogen is bonded to either oxygen, nitrogen, or fluorine. The strength of van der Waals forces depends on the factors. The first is size of the molecule. The bigger the size, then we have more electron, then we'll stronger. The second one is the surface area, and the third is the polarity of the molecule. The dipole, that's forces of attraction between oppositely charged ends of polar molecules. The hydrogen bond, electrostatic attraction between two polar groups that occurs when hydrogen covalently bond to highly electronegative NO and F. Here, this one is covalent between H and O, one molecule, this the other molecule, and between one molecule to the other molecule there is hydrogen bond. So hydrogen bond is intermolecular forces. There is another type of intermolecular forces with the term ion dipole forces. That's between the positively charged ion and negatively charged ion with the polar molecules. For example, when we dissolve Na plus Cl minus ionic compound, then the positive ion of sodium will face oxygen with the higher electron cloud here, and the negatively charged ion Cl minus will face H with slightly positive, or the positive pole of the H2O. This we call as ion dipole forces. The hydrogen bonding, and then here we have peculiar properties of water. First, we use water as solvent. Then water has high heat capacity. Then the density and freezing properties, that anomaly of water, and the surface tension. We can mention here five properties of water. The first is attraction to other polar molecules, then store heats, and then low density of ice, and the high polarity of water molecule. So when we drink water with ice cube, you may notice that the ice cube float on the water. That's because the density of ice is smaller than water, so the ice cube will float on the water. That's because in ice the hydrogen bond become stronger, so the volume will be bigger because the density is mass over volume. Then when the volume is bigger, then the density will be smaller. With smaller density, then the ice cube will float on water. We'll continue with metallic bonding. There is certain bond not between two atoms but in one type of atoms in metal. Metallic bonding is an electrostatic force between the positive atoms of the metal. Why become positive? Because the metal atom release the valence electron. The valence electron cause sea of electrons here. Then the positively charged ion of metal atom will swim in the sea of electrons. There is strong attraction between the negatively charged electron and the positively charged metal ion. For example, here we have silver. Silver is a metal. The atoms lose their valence electron and become positive ions. The negatively charged valence electrons move from ion to ion. So here the electrons moving around. The valence electron we say as sea of electrons that not bond to one atom but moving around the positive ions. We review what you know about properties of metal. Maybe two words, malleable and ductile. Malleable, that the metal particles we can press into sheet, become flat, and then ductile can be pulled into wires, so become long from one side and other side. We pull this, so become long. We'll compare the properties of metal and non-metal. Here you have So once again, so what is metallic bonding? A metallic bonding is produced when electron orbitals or valence electrons overlap and all electrons are shared between atoms, so not bond to one atom particularly. This is often referred as sea of electrons and is responsible for the high conductivity, refractivity, malleability, and ductility of metals. What is metallic bonding? Once again, metallic bonds are the forces of attraction between free-floating valence electrons and positively charged metal cations. In metal, cations are packed closely together. The loosely held valence electrons of the metal atom from a sea of electrons that drift freely from one to other metal atoms. So the metals still neutral. So please do exercise question number 11 to 14, page 64 of your